In this paper, we present the first fully automatic 3D markerless outdoor motion capture system. We use multiple autonomous micro-aerial vehicles, each equipped with an RGB camera and onboard computation capabilities. Our motion capture system consists of 3 steps.
Step 1 is a data collection step, where a team of MAVs autonomously follow a subject while keeping it in the camera field of view. We use the algorithm from Talamraju et al. For MAVs motion planning and from Price et al. For global pose estimation of the subject and MAVs.
Step 2 is a refinement step. Due to limited computation capabilities, all the observations cannot be used in step 1, instead all of them are saved to disk. We rerun the global pose estimation algorithm offline on the collected data to get better estimates of subject and MAV's pose. In step 3, we first detect 2D joints of the subject on each camera plane. Then we fit a state-of-the-art body model to these 2D joints, simultaneously for all the cameras for every frame. Finally, we compare our reconstructed mesh sequence with the reference sequence. We recorded IMU measurements during the experiment and reconstruct the reference SMPL mesh sequence using the method from Marquardt et al. In this comparison, we fix the global position and orientation to be 0. The blue mesh is the reference mesh and red is our reconstruction. Now we show a smooth version of our reconstruction. Here we perform Kalman smoothing over joint angles using constant position model.
Kalman smoothing is only used for this video. It is not part of our algorithm as it increases the error. Here we show our reconstructed mesh overlaid on each camera plane.